Is there any questions from last week? Anything that you need to clarify, or you good with it? Anyone need any clarification and you good with last week? Too easy. You remember the factors that we talked about? Volatility,
dividend, interest rate, share price, and
underlying price, right? Not necessarily share. Okay, whatever. Time to expiration.
Exercise price.
Exercise price, very good. So you got full marks. Okay, so if there's no questions, we move on to today's topic. Now, last week we talked about the factors that affect the value of an option. So today we're going to make use of our knowledge of those factors to basically value an option using the binomial option pricing formula. Last week we also talked about early exercise of American options, right? I hope you still remember the condition. Would you exercise an American call early? What do you think, sir? The one in black. Yeah. Would you ever exercise an American call early if it doesn't pay a dividend? No. No. Would you ever exercise an American put early? How about you, sir?
Yes.
Yes. Why is that so?
You can receive a money.
So that's one of the reasons, right? But there are more than one reason. Okay, so we'll also look at conditions to which we would want to exercise an American call early, and how we can account for dividends in the pricing model, and how we could actually determine at each node, at each time frame, whether or not it makes sense to exercise early. For we mentioned last week that just because an American option gives you the ability to exercise early, it doesn't necessarily mean that an American call would be worth more than a European call, right? It depends on whether there's value attached to that ability to exercise early or not. If not, then both calls would be about the same price. However, for American put, it's different, because for American put, there's always a situation whereby you want to exercise early. So you find that an American put can tend to be more valuable than a European put. So we'll look at all of that in today's pricing model as well. So we start off with a single period before moving to a multi-period. A multi-period, essentially, based on what we're looking at, will be basically a two-period model. Okay, and in your exam, you won't be tested beyond a two-period model if a binomial question comes out. But it's useful for you to know that you can actually extend that to as many periods as you want, hence it's called a multi-period. And then we'll also look at pricing puts. Now you know pricing puts there's a main difference between puts and calls, right? And that lies in the payoff of a put compared to a call, right? So when you price options, you have always to bear that in mind and switch the payoff. And then with American options, as I mentioned, we'll look at how to account for dividend, how to account for early exercise. How many of you are familiar with binomial probability distribution? You are. Okay, for the benefit of the rest, I'll just do a recap of the binomial concept. So in a binomial model, as the name suggests, you can have only two states, right? So it either goes up or it goes down. Yeah? Now, having gone up, of course, it can continue to go up, or it can then go down. And likewise, having gone down, it can go up, or it can still go down, right? So it's always, at every node, there's only two outcomes, either up or down. So if this were expiration, let's call this T2 and this is T1, then basically what we're saying here is that we're looking at a two-period binomial model. Now, binomial model is often described as a discrete model. However, it is discrete with respect to time. So for a one-period model, you can determine the time period to be whatever you desire. So if you think that one period is 1 day, then it is 1 day if it's, so this is 1 day and this is another day. Or you could think of this as 1 minute, let's say. Now if you were to slice that time block into smaller parcels, right? So if it's 1 minute and you slice it, so if this is 1 minute and you slice this into 60 slices, so it becomes 1 second, right? So as you slice the time period into smaller and smaller parcels, then you find that it approaches real time. Yeah? So time becomes continuous. So as you do that, that means that it becomes a multi-period model, right? So then you find that the value of your option calculated using binomial model would then approach a Black-Scholes model because now they're both continuous time. Okay? So it doesn't mean that binomial model is not real, it's not continuous. It's simply based on how you define your time period. Okay? So for simplicity, we will of course define a longer period. Otherwise, it will be very cumbersome to calculate so many periods in your binomial model, right? You can't actually do it by hand. Now, okay, so let's just call this a stock. Okay. Now, if this were a stock and it goes up by p, it would go up by a probability of p, and of course, it go down by a probability of 1 minus p. And p is given by 1 plus r minus d, u minus d. Now, it's convenient to look at p as if it's the probability of an upward movement or the probability of a downward movement. Now, however, if you look at the little formula I wrote for you, it's actually the probability of risk neutral, right? It's not so much as the probability of going up or going down, although it's convenient to think that way. And P is, of course, governed by the binomial probability distribution. Now, if it goes up, it will go up by a factor of u, and if it goes down by a factor of d. And P, u, d are all constant across the period. Okay, it's assumed to be constant. Now, u and d essentially are defined as 1 plus rate of return. Okay, and you find that d, a downward movement, is less than 1 plus r is less than u. Okay, so what that suggests to you is, based on the formula here, d is less than 1 plus r less than u, is that there's a basic assumption here that the underlying instrument over time must grow by the risk-free rate of return. Okay, so you're assuming that over time, the underlying instrument, in this case the stock, must grow by at least a rate of return equivalent to the risk-free rate. All right? Hence, a downward movement is less than this, and the upward movement is more than this. So going by this, can both be a positive number? Can d and u be a positive number? Yes or no? Okay, we'll look at an example. Now, if this were an underlying, you value from left to right. Okay, so you start at time 0, and then given p, given u, given d, you value it towards expiration. Right? So given strike price, given interest rate, we can now value options, right? So if these two nodes here, having gone up and gone down, or having gone down and go up, if this value and this value, let's call this SU, SD, SUU, SUD, and SDU, and SUU, right? So it goes up, and then it comes down. So SU, and then SD, so SUD, right? So if SUD is equal to SDU, such that these two nodes are the same, then we call that a recombining tree. or path independent. Okay, so it doesn't matter whether it goes up first or it comes down, or it goes down first and then goes up. We come to the same price. So it's independent of the path. Now it may not be so obvious to you the significance of it at this moment because we're looking at plain vanilla options, but when you begin to look at exotic options, then path independence makes a difference to your exotic options. Okay, so bear that in mind. Any questions so far? So we can then value option, whether it's a call or put, right? And again, this would be T1, this would be T2. Now, when would you value option? Can you start from here? Just like you do with your stock. In your stock, you start from here, and given U and D, you value it from left to right, right? From left to expiration. Now, with an option, can you do the same? Why not, sir? Yes, but we have the underlying value, right? We have already calculated the underlying value. So if
it also has a time value.
Yes, very good. So what is the significance of that? The time value that you mentioned. Why can't we value from left to right? Because we're saying that we can value the underlying from time 0 to time t2, right? But with options, can you do likewise? Now you say that you can't because of time value. So can you explain that a little bit more?
Sorry, I can't remember.
You can't recall it. Does anybody want to help me out? That's on the right track. Does anybody want to make a guess? Okay, now with options, you have time value, right? Now time value is speculative value, so you do not know. Now there is time value here. Is there time value here at expiration? Yes or no? No. Why isn't there time value at expiration? Because at expiration, an option is either in or out of the money, right? So if it's in the money, then it's positive. If it's out of the money, it's worthless, right? So at expiration, what it means is that you know the value of an option with certainty. There is no question about whether it is positive or zero, right? So hence you can tell with certainty, and therefore you value an option backwards from expiration to whatever time you want. So you can value the option here, because if it's in the money, then there's a value. If it's out of the money, then it's zero, right? And with that value, you then discount it by one period to these two values, and then you discount it another period to this value. Okay? Because the value of an option is essentially its payoff, right? And the payoff is certain at expiration. And if you want to know the value before expiration, then it must be the discounted present value. Okay? Any question? Okay, so here I have a stock that is $10, and if it goes up to $13. If it goes down to $11. Is $11 a downward movement when the stock is at $10? What do you think, Maggie? Is $11 considered a downward movement when the stock is at $10? Well, you could call that a downward movement, because remember what is U and D. U is greater than 1 plus R, and D is less than 1 plus R, right? So if the rate of return, if the movement is higher than the rate of return, then it's an upward movement. If it's lower, then it's a downward movement, right? So if it's $13 and rate of return is $12, then obviously this is an upward movement, this is a downward movement. Okay? So the value of an option at expiration, 1 period model, in an upward movement is $1 because it's in the money, right? 13 minus 12. And it's 0 if it's out of the money. Okay, and how do you get 0.09? Well, you simply discount it by 1 period. Okay, given the interest rate. Any question? Okay, so if you look back at what I drew for you here, have we accounted for all the factors that we talked about last week? We have time, right? We accounted for time. We have the underlying price. We have strike price. We have interest rates. So where's volatility? That's reflected in the up and down movement, right? So we've taken into account everything that we spoke about last week. So here's a question. Given that we can create synthetic shares using calls, can we hold both calls and shares to cancel out our net position? So what we're moving into is a hedge portfolio. So the idea is this. If you were to hold a portfolio of risky assets comprising options and its underlying, okay? And if you were to hold that portfolio in the right combination, okay, the right ratio of underlying and options, then essentially you can create a riskless portfolio. Now with a riskless portfolio, what kind of rate of return would you expect to earn? Risk-free rate of return, right? So riskless portfolio created in this manner would give you a risk-free rate of return. Now given that it is riskless, it also means that you're no longer concerned whether the underlying price goes up or goes down, right? Because the value of an upward movement in your portfolio and a downward movement must be the same because it's riskless, right? So if it's riskless, it doesn't matter to you which direction does the underlying price move. So the ratio or the combination in the portfolio is denoted as the small letter h here, and it's also known as the delta h. Okay, so that's the hedge ratio, and this is what is called a delta hedge. So if you start off with going short a call, minus, right? You go short a call, then according to the hedge ratio, you should go long hedge number of shares. Okay? And we'll look at how to determine the hedge ratio in a while. So if you hold hedge number of shares and you short a call, this will be your the value of your portfolio at inception. If the stock price goes up, then the value of your stock and options changes to SU and CU and SD and CD if it goes down. And VU and VD must then be equals to each other because it's riskless, right? And it must also then be equals to the value of your initial portfolio compounded by the risk-free rate of return. Yeah? All good? And you can solve for H. Given that VU is equals to VD and VU is equals to HSU minus CU, okay? Simply replace HSU minus CU into VU. You can solve for H, and H is given as CU minus CD, SU minus SD. So H here then is the ratio in which you must hold your underlying and your options. Okay, so for every call, so suppose H is, let's say, 0.5, what that means is that for every call you short, you must therefore long half a share. Okay, but because you can't buy or sell fraction of a shares, you must always round that up to a whole number. Okay? And solving further for C gives you this formula here for a call under the binomial model. So a call is given by PCU. P is the probability of an upward movement, and 1 minus P is the downward movement. So CU and CD is, of course, the value of a call if it goes up or goes down. So value of a call is therefore equals to PCU plus 1 minus PCD discounted to the present moment. So if you look at the formula carefully, what really is the value of a call? It's nothing but the discounted expected payoff of an option, right? Because the numerator is simply the expected payoff, right? And the denominator is where you discount to the present value. Hence, the value of a call or a put, for that matter, is simply the expected discounted expected payoff. Okay. Question? So what's risk neutral pricing? Now with options, we said last week that we like volatility, right? In other words, we like risk with options, but we don't like risk as much when we look at another asset such as a stock, right? So in options, we have what is called a risk neutral pricing. So what is risk exactly is risk neutral pricing? Well, it's based on the simple idea that risk can be eliminated through a process known as dynamic hedging. Okay, dynamic hedging means you delta hedge continuously. Okay, so that's dynamic hedging. Now, once risk is eliminated in this way, the value or the expected return of your asset must therefore be equal to the risk-free rate, right? So attendant to that fact, therefore, is that assets grow at the risk-free rate of return, and similarly can be discounted at the risk-free rate of return. Okay? So if it's risk-free rate of return, then you're saying there's no risk, right? You're neutral to risk. Now, in finance, we always talk about risk and return, right? Two key tenets of finance. So in any asset pricing formula, you must always account for risk. But in options, we don't account for risk. Why is that so? Why isn't there any risk? Now, if you look at the formula I have for you before this, where's the risk? There's no compensation for risk, right? So why isn't there a compensation for risk with options when we must always account for risk in any other asset pricing formula? What do you think? What do you think? You know the answer. Think. I'm sure you know the answer. Because we said so many times, right? With options, especially when you look at it in terms of the favor, you don't have a risk, right? Why is that so? Yes, because you can walk away, right? So your option is either in the money or out of the money, and if it's in the money, it's beneficial to you. If it's out of the money, you walk away losing a small premium. Effectively, a small premium is a sunk cost, right? Anything that you do, there is a sunk cost, right? If you go to a club, you pay a cover charge, that's a sunk cost. Whether or not you enjoy yourself at night, it's a sunk cost, right? So similarly, you buy an option, it's a sunk cost. So there's no risk involved. Now, with an asset pricing formula, let's say, what are you familiar with? CAPM? Yeah? Okay, what's the formula? Equals to risk-free plus beta market return minus risk-free rate. Okay, so what is this? So this is a simple asset pricing formula, right? For most assets. So what is RF? What is that? What does that compensate you for?
For what you can get from the bank, or risk-free bonds.
So is that a compensation for risk? Time value, right? Very good. It's compensation for time, right? So where are you compensated for risk? So with the key tenets of a risk and return, the idea is that if you take a greater risk, you would expect a greater return, right? Hence leading to what is called a risk premium. Okay? So with most assets you would expect to be compensated for risk and a risk premium, right? So where's the risk and the risk premium here? This is your risk, right? The beta of the stock. Yeah? And you have this term too, right? So you're compensated for your risk, and there's a risk premium in there. But with options, you don't see the same thing. You don't have a risk premium, you don't have a compensation for risk, because with option, there is no similar kind of risk because you can walk away. Okay? Any question? Okay, if not, we'll look at an example of a one-period model. Now, I'm sure many of you will find the calculation very simple. Okay, some of you may find it too easy, and indeed, the calculation is not difficult. Okay, but nonetheless, I will go through in much detail. The main thing I want you to take away from it is not so much as the calculation, because it's so easy after all. The main thing you want to be able to take away is which values to take in your calculation, whether you're taking the current period value or the future period value, and into your calculation to determine the price of your option. And the other thing I want you to be able to take away is also which value to use, whether you're using the discounted value or are you using the intrinsic value at each node of the way, okay, at each node that you're looking at. Because that has a bearing on your decision whether or not to exercise early. Okay, and if you take the wrong value or you don't know which value to take in your calculation, then obviously your final result is going to be incorrect. And that's the source of error for many students in the past. Okay, the calculation itself is very simple, just be mindful of where the numbers come from. Okay, so that's the main takeaway that you want from the examples. Okay, so let's first calculate the price of a call. So given that S is 200, strike price 200. Now, as I said, U and D are 1 plus rate of return, right? So this is obviously a 25% upward movement, and this is a 20% downward movement, okay? So contract size, assume 1 for 1. Now, similarly in your exam, you must assume 1 for 1 as well, unless you're told otherwise, okay? Because in topic 1, you know that it's not 1 for 1, right? In the contract multiplier, like in Australia, it's 1 to 100, right? So if in the exam it is silent, don't assume 1 to 100, okay? Take 1 to 1 unless you're told otherwise. So first you find the values of CU and CD, and then you can find the value of H. So what is CU? Well, the value of a call is equals to the greater of 0, or its intrinsic value at expiration, right? So what's the intrinsic value? Well, it's 200 stock price times 1.25 if it goes up, minus the strike price, right? So it's 50 because it's in the money. So essentially it is, so CD is 0 because it's out of the money, okay? Everyone follow so far? So how do you calculate H? Well, it's simply CU minus CD divided by SU minus SD, right? So CU minus CD divided by SU minus SD. So it gives you 0.556, and you have to make it into a whole number because you can't buy half a share, okay? So P is 1 plus R, okay, minus D divided by U minus D gives you 0.6. So therefore 1 minus P must be 0.4. So stick that into your formula. The value of a call is equals to P, okay, 0.6 PCU plus 1 minus PCD divided by the interest rate, okay? So that gives you 28. So then we look at a hedge portfolio. So we've calculated that the value of a call is 28 and the hedge ratio is 0.5. Okay, so what you need to do if you short a call, if you were to short one call, you need to go long 0.5 shares. Okay, so you times that by 1,000. So you short 1,000 calls, and you long 556 shares at 200. Short the call at 28. The value of your portfolio is 83,000. Okay, so if the stock price goes up to 250, the value of your call goes up by 50, right? Because 250 minus strike price of 200 gives you 50. So the value of your portfolio now becomes, you still have 556 shares because it's one period, right? So you don't readjust your portfolio. So 556 shares times 250 now, okay, 1,000 calls that you have times 50. So it gives you 89,000, which is a 7% return, which is our interest rate in the preceding slide, right? We said it's 7%. Now, if the stock price goes down to 160, your call is out of the money, so it's 0, right? So did you make money or did you lose money on your call when the stock price goes down? What do you think, man? Did you make money or lose money? So you short 1,000 calls at 28, right? And when the stock price goes down to the 60, the calls are worthless. So did you make money from shorting your call or did you lose money from shorting your call? You make money, right? Because when you short the call, you collected the premium. Okay. However, you lost money on your shares because you bought at excuse me, you bought at 200 and the price has gone down to 160. But we said that when you correctly hedge your portfolio, it doesn't matter, right? So the value of your portfolio is 88,000 due to rounding off error. Again, you have roughly 7% return. So it shows that if you were to hedge correctly and your hedge ratio is correct, in this case you don't have to rebalance because it's one period. But if it's multi-period, you will need to rebalance. But if you hedge correctly, then it does not matter whether the underlying price goes up or down. You will still end up with a risk-free rate of return. All right? Any question? You seem deep in thought. Anything you want to clarify? Okay, good. So you invested 83,000, you got back 89,000, a 7% return. Which is also what you're going to get if you stick your money in the bank, right? You still get 7%. Yeah? So why do we bother to do that? Why do you bother to do that if you're going to get the same return as if you stick your money in a bond or in the bank? Well, here's the thing. If you put your money in the bank and earn that 7% rate of return, that is all you get, right? No more, no less. Agree? Now, if you do something like this and there's a mispricing in the market, then you stand to gain more. Okay? So if the call is overpriced, now we calculated the fair value to be 28. If it's selling now for $30, what do you do? What do you do with an overpriced asset? Do you sell or buy? You sell, right? So you sell the call for $30, which is more than our example earlier on at $28, right? So as a result of that, you find your capital outlay is less than 83,000 now because you collected more money from shorting your call. Yeah. So you still end up with 89,000 at expiration, right? Because regardless of what happens, your 89,000 doesn't change at expiration, right? Because U and D are constant, remember? So you still have 89,000. So 89 over 81 gives you a 9.6% return, which was higher than the 7% risk-free rate of return. So you find that you can actually capitalize on mispricing using delta hedge, as opposed to if you just put your money in the bank. Okay. Now, what happens if this is if the call is underpriced? So if it's underpriced, you would go long the call, right? You will buy the call. And when you buy the call, what do you do with the underlying? Do you buy or sell the underlying? Why do you sell the underlying? Well, it's a correct answer, but I want to make sure that you understand the logic, right? So that when it comes to put, you know what to do. So why do you sell stock when you long call? So in the earlier example, when we short the call, we long the stock, right? So now you long the call, why do you want to short the stock?
Price of the call and price of the share goes in the opposite.
The price of the underlying and the price of the call goes in opposite direction. Same direction. So why do you short the stock? Okay, this will help you to figure out when you go to put, right? So if you don't start thinking of the logic behind it, then you find that you're going to have to spend a lot of time learning and memorizing everything, right? But if you could reason out for yourself, then you find that it's an easier process. Want to make a guess? Do you want to make a guess? People at the back? Okay, when you short a call, what happens? You have the obligation or do you have the right? You have the obligation, right? So if someone exercise that call, what do you have to do? You have to?
Sell the underlying.
No, you do not have to sell. What do you have to do? So you short the call, you collected the premium and you assume the obligation, right? So if that call is exercised on you, what do you have to do with the underlying? So if that call is exercised, they pay the premium, they pay the strike price to you, right? And what do you have to do? Yeah, you have to deliver the shares, right? So in order to deliver the shares, you need to have the shares, right? So therefore you long the stock. No, you long the stock. When you short the call, you long the stock, right? So that if it's exercised on you, you have the stock, right? You follow? So you can apply the same principle to puts later on. Okay, coming back to an underpriced call. So the call is priced at 26, which is lower than 28 before. So what do? You buy the calls and you sell the shares, right? At the same price of 200 and this time at 26. So when you buy the call at 26, compared to market value of 28, you're buying it at a cheaper rate, right? Now, it generates a cash inflow of 85,000. Why do we say it generates a cash inflow? Because you sold the stock, you collected more money from the stock than what you pay out for the call, right? Yeah, so you receive money. And what do you do with that money? You can stick it in the bank and earn 7% return, right? And at expiration, it's the same thing at 89,000. So this is like a loan in which you borrow 85 and you pay back 89. So 89 over 85 is 4.4% return, which is still lower than the risk-free rate of return, right? So the idea is this. With a risk-free rate of return, you assume that you can borrow at the risk-free rate of return. You also assume you lend at the risk-free rate of return. So it's two ways, right? So if you put money in the bank, you're going to receive interest rate at the risk-free rate. If you were to lend someone money, you're also going to lend it at the risk-free rate of return. Okay, it's the same interest rate. Of course, in reality, it's not the case, right? If you put deposit in the bank, you're going to earn less interest than if you borrow money from the bank, right? So that's how the bank makes money. So in reality, it's a somewhat different story, but in theory, we say that the risk-free rate of return applies to both. Okay? Is the term borrow here, borrow or lend, confusing to you? Can you figure that out? Why do we say it's as if you borrow 85,000? You receive 85,000, right? Why do we say that it's as if you borrow 85,000? No, it's actually much simpler than that. Okay, if you You receive money, right? 85,000. If you borrow something, do you receive or do you give up? You receive, right? So therefore, you borrow, right? It's as if you borrow. Now, when you lend someone something, you give up, right? Yeah? So the opposite logic applies, okay? So then it becomes very simple for you to remember, right? Because whether you borrow or you lend, you know, you can quite easily think through. That's not cheating, right? That's just showing you a simple way to think through the process. Okay, so now we look at a multi-period model. Any questions up to this stage? Okay, so this is recombining or path independent because SUD and SDU is the same value, okay? So in a multi-period model that I have here, we're looking basically at a two-period model. So CUU or CU squared is basically the value of the option at the end of the two period, right? So that's expiration. So you know with certainty it's either in the money or out of the money. So you take the value of the stock 2 periods out, strike price remains the same, right? And you calculate the value of your options at the end of the period 2. So to determine the value of the call in period 1, you simply discount it by 1 period, right? But remember now, although it's the same basic formula of PCU plus 1 minus PCD divided by 1 plus R, you're using a different value now. You're using the end of period 2's value for your calls, okay? So essentially it's this, right? So to determine the value of your option here, you use the value here, discount by 1 period. If you want to value here, then you still have to start from here and you discount by 2 periods, okay? Discounting by 1 period gives you the value of your options here and you discount by another period. So if you're very familiar, you can simply use a 2-period formula. If you're not so familiar, you can still achieve the same result by taking one extra step, okay, by discounting it twice. So this was discounted to T1, and now this is discounted to the present moment. Okay, if you want, you can also use a 2-period formula. All formulas will be given to you in the exam. Okay, take a look at that. Sorry. It's not working. Okay. So all formulas will be given to you. So instead of memorizing the formula, you want to use the formula in your studies. Okay? So as you read, try and relate that to your formula because it's a closed book exam, right? So you can't bring in your notes and everything, but you're given the formula. So as you prepare for the exam, if you can relate that to your formula, then essentially you have a cheat sheet, right? Because I've given it to you. Right? You have the formula, and if you can relate the theory to the formula, then looking at the formula, perhaps it can help you remember the theory. Okay, so don't think that a formula is just for you to do calculation. Okay, so I mentioned about dynamic hedging, right? So in a 1-period model, we calculated the hedge ratio once. Now in a 2-period model, you need to recalculate your hedge ratio because the price has changed. Okay. So then, using the same formula of CU minus CD, SU minus SD, you simply use the correct periods prices to calculate your hedge ratio. Okay? So the hedge ratio, if it goes up, will be this value. If it goes down, will be this value. Is there any question on this slide? Any question? How many more slides do I have? Okay, again, S is 100, strike price is 100, the same parameters as we had before. So you can calculate the value of the underlying if it goes up in 2 periods, right? 25% yield factor is constant over the 2 periods. So now that you know the value of your underlying at this period, at the end of T2, you can calculate the value of your call at this period as well, because it is simply the intrinsic value of 0, right? Depending on whether it's in or out of the money. Okay? And then you discount it using the binomial formula to calculate the value at T1. Any question? And then to find the value at T0, you discount it one more time. Okay, so the formula is the same throughout. You just need to know which values to use in your formula. Is there any questions that you want to ask? Okay, so earlier on we looked at hedge portfolio for a 1-period model. So now we're going to look at a 2-period model. So call trades at its theoretical or fair value of $17. So the hedge ratio is CU minus CD, SU minus SD, so it's 0.7, right? So you buy 701 shares, and you sell 1,000 calls because you need to make this into a whole number. Okay, net investment is 52, so very simple. So here you have a stock that starts off with $100. It can go up to 125, or it can go down to 80. It can then go up to 156 if it goes up to 125. From 125, it can go to 156, or it can go back down to 100. And from 80, it can go up to 100, or it can go down to 64. Okay, so left to right. Now, the call is, so you short the call at $17 per call. Hedge ratio is 0.7, so therefore you long 701 shares and you short 1,000 calls, give you a value of 52,000. Okay, and in period 1, the call has gone up to 31.54 in value because the stock price has also gone up to 125. Okay, so the value of your portfolio then, you still have 701 shares. Now this slide may look very complicated because there's so many numbers in there, but it's actually quite simple. Again, I want you to take note of where the numbers come from and to be able to interpret the numbers. Okay, so calculations are all very simple because you studied calculus in primary school, right? Okay, so then the value of your portfolio, is it 11 o'clock? No, right? Okay. So the value of your portfolio is 701 shares times the new stock price minus you still have 1,000 calls times the new call price gives you 56. 56 over 52, you have 7%, which is your risk-free rate of return. Now, however, hedge ratio has changed, right? Because the prices have changed. So in order to hold your portfolio for another period until expiration, you need to rebalance your portfolio. So if you have many periods, then you need to rebalance your portfolio many times. So that's called dynamic hedging. Okay. And with dynamic hedging, you find that it's actually not so easy to do. Right? As an individual, you probably find that you can't really do it because the stock price doesn't jump from 100 to 125, right? That's because we assume time to be in blocks. But time is actually continuous, right? So it moves from 100 to 125 in many steps, right? So if you were to do dynamic hedging or delta hedging correctly, you have to rebalance at every step. So from 100 to 125, where we consider as one period, is actually multiple periods, right? So imagine instead of rebalance one time, you actually rebalance thousands of times in that period, right? So in reality, it's not so easy to do. You need facilities, right? You need supercomputers, you need very fast feedback of the stock prices and so on and so forth in order to keep churning out new numbers for you to rebalance, and then you keep having to buy or sell your calls and stocks, right? So in practice, it is quite difficult. Okay, so now you calculate your new hedge ratio. So hedge ratio is 1 this time. How do you get 1? Again, you use CU minus, okay, I might as well put all up. Again, you use CU minus CD, SU minus SD, right? So how do you get 1? Well, you simply take CU, 5625, minus CUD, which is 0, divided by 156 minus 100, right? CU minus CD, SU minus SD. Does everyone follow? Okay? So that gives you 1. So what does a hedge ratio of 1 mean? Well, it simply means that for every call you long or short, you must therefore short 1 or long 1 shares, depending on whether you long or short the call, right? So it's a 1-to-1. Now, we have started off with 700 shares to 1,000 calls. So this is no longer correct ratio now. If you expect to earn risk-free rate of return in this period, then you have to change your portfolio. You have to rebalance your portfolio. So in order to do that, you have two choices, right? You can either buy 299 shares to make it 1,000 because you have 1,000 calls, right? Or you buy back 299 calls so that you reduce your calls to 701, right? So you can do either one. So in my example here, I choose to buy back 299 calls, okay? You can do either one, but it's cheaper to buy back calls, right? So I buy back 299 calls at what price? At the prevailing price, okay? So I have to spend 9,430. I assume I borrow 9,430. So my new portfolio now is I still have 701 shares, okay? But I now have only 701 calls because I have bought back 299 calls, and the shares and the calls are at the prevailing price, okay? 125 and 31.54, and I also have a debt of 9,000. All right. Now, if the stock price goes down, then my call is out of the money, right? Because 80 minus 100, strike price of 100 is out of the money, so it's worthless. My portfolio is now 700 times $80, and my calls are worthless. I still have 56,000, which is again a 7% return. All right, so it does not matter whether the stock price goes up or goes down. If I hedge it correctly, I will still get the same rate of return. All right, so that's something you can think about in your own investment. All right, this course is actually quite alive, at least as far as I'm concerned, because you can use many of the principles and the techniques later on when we look at option strategies in your own investments or maybe in your parents' investments. You can be your parents' fund manager or something like that. Okay, so if the stock price goes down, then the value of your portfolio still earns you 7%. However, your hedge ratio this time, when the stock price goes down, is 0. So what does that mean? Why is it 0? So 0 means you don't need what? What don't you need? You don't need your shares, right? Why don't you need your shares? There's a logical process to think through this. Somebody said something? Was it you? It's deep out of the money, right? So it's not going to be exercised on you, so you don't need to hold your shares. Well, remember earlier on we said that when you short the call, you need to long shares, right? For what reason? For delivery, right? Because it's exercised on you. Now there's no chance of exercising, right? So you don't need your shares. So you can see that if you start to think in the right manner, they actually flow quite well, isn't it? You can think from one concept and relate it to another. Okay, so you don't need shares anymore. So you sell your shares at $80. Okay, and what do you do with the money? You stick it in the bank and you earn a risk-free rate, right? Yeah? You have the money. If you want to be safe, all you have to do is stick in the money, stick in the bank, or you buy a risk-free bond and you earn the same rate of return. Now coming to expiration, the stock price has gone to 156. Your call is in the money, so 156 minus strike price of 100 gives you 56. If it goes up and then if it goes up to 125 and then goes down to 100, your call is out of the money, right? 100 minus 100. Okay, and if it goes down from $80, if it continue to go down to 64, of course your call is even deeper out of the money. Even if it goes back to 100, it's still out of the money, right? So whether it goes up to 125, goes down to 100, or it goes down to 80, goes up to 100, your call CUD and CDU is the same value and is both out of the money. Okay. Now stop me if you have a question. Okay, I want to make sure you understand this slide. Okay, so the value of your portfolio now is, how many shares do you have? 701 shares, right? So 701 times the prevailing stock price minus 701 calls, because you're short, right? Times the prevailing price, and then you have a debt, right? That you have to pay back at the risk-free rate of return, because we always assume that we lend and borrow at the same rate. Okay, so you end up with 60,000. 60 over 56,000 is equals to 7%. Okay, now likewise, if the stock price goes up first or goes down and then goes down and goes up, your call is still out of the money. The value of your portfolio is still 701 because that's brought forward from the previous period, right? So you hold 701 shares and you hold 701 calls, and you have 60,000, which is still 7%. If the stock price goes down first before it comes up, again you hold, your value is 60%, regardless you still own 7%. So likewise here. So you can see from this slide that regardless of what happened to the underlying price, you continue to earn your risk-free rate of return in every period, right? What is the value of CU 3154? What is it? Is there a time value in 3154? What do you think? You think there's time value in 3154?
Yeah, just that period, just that T1.
Okay, you would assume there is time value, right? Because there's one more period to expiration. So can you tell me what is the time value there? What is it worth? How much is time value in CU? No, you know. Don't say you know, sure. You know. I'll tell you why you know. You know the value of an option is comprised of intrinsic plus time, right? So the value of the option is 3154. Can you calculate intrinsic value there at that point in time? Yes or no? What is intrinsic value? Okay, what is intrinsic value? What minus what? S minus X. So what is S minus X there? S is 125, right? And at that point in time, agree? X doesn't change, right? It's whatever 100, right? So what is intrinsic value? So what is time value? See, I said you know the answer. Okay? You just need to think. Okay, so time value is 654. How much is time value in C? How much is time value in C? Okay, you didn't give me that answer just now. What now?
So first of all, intrinsic value.
Yeah, so what is time value? How much is time value? Yeah, X is track price. Exercise price, same thing.
Yeah, it's a price.
100.
Okay, so
Oh, you don't remember, it's in the preceding slide, right? Okay, it's 100. So how much is time value? Okay, how much is time value? How much is time value? Come on. Strike price is 100. Stock price is 100. The call is valued at 1769. How much is time value? 1769, right? Yeah? Okay, so you can see from here that now what did we talk about in terms of time value last week? Depends on time use and moneyness, right? So can you apply that here? How?
It's a longer period to expiration and extend money.
Okay, you can see that 2 periods to expiration, time value is 17 and 1 period is $6, right? What else can you tell me on the second principle that we learned? Someone else?
Now to add the money.
Sorry?
The time will maximize.
Maximize add the money, right? Yeah, that's what we talked about as well, right? And when it's deep in or out, the money is irrelevant, right? Time value is not important, right? Which we can see from here as well, okay? Okay, so a couple of things you want to take away from this slide. You want to know where the numbers come from, okay? Which number to use. You need to be mindful that you have to rebalance your portfolio, meaning you have to recalculate your hedge ratio, okay? Because your hedge ratio changes in every period. And the reason why I point out the time value to you is that it gives you a means to cross-check yourself. So you know whether your calculation is correct or not. So you know that time value increases with time to expiration. If now you have, 654 time value in time 0 and 17 in time 1, you better check your calculation, right? So there are many ways that you can actually not just learn option. There are many ways that you can check your understanding, check your answer in the exam, and hopefully you do better. Okay? So these are techniques that you can use to help yourself. Okay, any question on this slide? No? Okay, we spoke about this, right? Funds realized are invested at 7%, and funds are borrowed at 7%. So if option is correctly priced and you maintain the appropriate mix, you would be guaranteed of that. Okay, so this is just a summary of what we've gone through, right? If it's underpriced call, you long the call, you short the stock. And if it's overpriced, you short the call and you long the stock. We went through how to figure out the rationale behind this before the break, right? So I have a question to you this time. Now, if it were not a call now, but if it's a put, and the put is underpriced. What do you do? How about you? And one in black. Okay. What do you think? Yeah. So if the put is underpriced, what do you do? You long put. And what do you do with the stop? Do you long or short the stop? You short the stop. Any different answer? You long the stop. Why do you short the stop, man? So you long the put because it's underpriced. So why do you short the stop? Yeah, but how does that hedge your long put? So you long stop, right? You long stop, right? You long put, you long stop based on the reasoning that we discussed before the break. Okay? So similarly, if the put is overpriced, you short put and you short the stop, right? Again, don't memorize. Okay, think through the process. Okay. So why do we long put, long stop? Because when we long the put, and if we exercise the put, what do we have to do? We sell, right? So when we sell, what do we have to? What happens when we sell? What do we collect? We collect the strike price, right? What do we have to do with the stop? You deliver the stock, right? You collect the strike price, you deliver the stock, right? So if you long stock and you long put, you have the stock to deliver, right? Okay? Okay, for pricing put, it's the same thing. All you need to do is you need to be conscious of the payoff, right? Instead of S minus X, it becomes X minus S now. So here I have all the parameters. Notice that I'm using the exponential term this time. So stock price is 100. If it goes up to 110 or 90, R is indicated here, right? It goes up to 110 or down to 90, 2 months time. Okay, now notice that as well. I remember telling you that when you calculate your time to expiration, you always divide by 365 days, right? Notwithstanding market is not open. Now, if you're given in terms of months, then you have to adapt accordingly. Okay, so in this case, you're told 2 months, so you divide by 12. So calculate all of this. Okay, interest rate given to you. You know U and D are 1 plus R, right? 1 plus rate of return. So therefore, if it goes up to 110 or goes down to 90, your U and D is 1.1 and 0.9 time to expiration. So instead of discounting by 1 plus R, we are using the exponential term this time. Okay? Meaning to say we're assuming continuous compounding and discounting. Now in your exam, always use continuous compounding and discounting. Okay? Don't use discrete. Unless you're told to do so, of course. Okay? So what is P? Now, we saw that P was 1 plus R minus D, U minus D before, right? So when you use the exponential term, 1 plus R becomes e to the power of RT. And you stick in the numbers, it gives you 0.58. Any question? Okay, so the put is 0 when it's out of the money. This is the price of the stock, right? So 102 minus 90, 12. So this put is in the money. And you will notice also that the formula for put is the same as that for a call. All you have to do is change your C and P. Okay, substitute your C with your P. So now instead of PCU plus 1 minus PCD, you have PPU plus 1 minus PPD. Okay? And of course, instead of 1 plus R that we saw before under the discrete model, you use e to the power of RT to discount. Okay? So it gives you 4.9. So you can also price puts or calls for that matter using put call parity, right? Okay, so put call parity is put plus stock equals to call plus bond. Rearrange that if you want to calculate call, rearrange that again if you want to calculate put, stick in the numbers you have your value as well. Okay, any question on this slide? All good? Okay, so this is an interesting one. So, how many slides do I have? How much time do I have? Okay, so we discussed earlier on that the value of an option is effectively the discounted expected payoff, right? And it's discounted because we need to calculate the value at expiration first before we know the value today. And if you want to know the value today, we must always discount the present value, right? So for European options, it's quite simple to understand because it's the same thing, right? You can't exercise, right? So if you want to know the value of an European option today, it must be the present value of what it's going to be in the future, right? Yes? Okay? Now, with American options, however, it's different. Okay? Now, in last week, we talked about the value of an option is always the greater of 0 or intrinsic value at expiration. Now, with American option, because you can exercise early, and if you want to consider the value of an option today, it's no longer 0 or discounted value anymore, because if you exercise it today, what value do you get? Intrinsic value, right? So now you have to compare intrinsic value, which is x minus s, with the discounted expected payoff. Okay? And the greater of the two would then be the value that you're going to take. Now that makes sense, right? Because for an American option, if you were to consider the value today, if the value today is going to be the intrinsic value because you can exercise. Yeah? Now, if you don't exercise, then it becomes the discounted expected payoff, right? So there are two values to an American option now, and you have to consider which value is relevant to you under what circumstances. Okay? So if the intrinsic value is greater than the discounted expected payoff, would you exercise or not? Or alternatively, when would you exercise based on the two values? Okay, again. Now, so now you have two values, right? Okay? Intrinsic value and discounted payoff. Now, if intrinsic value is greater than discounted payoff, would you exercise your American option or not? Yes or no? Yes. Of course you exercise, right? So that helps you to determine whether or not to exercise an American option early. Okay? Now, given that you would want to exercise that American option, it would also mean that, so let's say now it's time t1, okay? So intrinsic value is greater than discounted value. So therefore you want to exercise, right? Now, if you were to value this same option at time 0, which value are you going to take? You will have to take the intrinsic value now, right? Because that's the greater value to you. If you want to take because if you exercise now, that's the value you can obtain, right? So therefore you take that value when you discount it into the current time. Okay? So remember that. Okay, how do we account for dividends? Because we know that with American calls, you will not exercise unless it pays a dividend, right? And the reason for that is because the stock price can go down and you can end up becoming out of the money. So how do you account for dividend? Well, if the stock is 100 and it pays a dividend of $12 in period 1, last week we said that you need to adjust the stock price with the present value of the dividend, right? Now, if we don't do that, what's going to happen? Well, it goes up to 125 or it goes down to 80. Dividend is only paid in period 1 at $12, so it becomes 113 or 68 ex-div, right? Now, if you were to use 113 and 68 at the same U and D, because U and D is constant throughout the periods, then you find that these two values are different, right? It no longer recombine, okay? That doesn't mean that you cannot value your options then, you still can, but you can't use this formula anymore, okay? So you need to adjust it by taking the, discounting the dividend to the present value. So you take 100 at time 0, dividend of $12 payable in period 1. So if you want to account for it in period 0, you have to discount one period, right? So therefore it gives you 88. Using 88 with the same U and D, it now becomes recombining, okay? However, you have to be mindful that dividend is $12, not present value of $12. Okay, dividend is only going to be paid in period 1, and therefore, although your theoretical value of your stock is 110, it has not paid a dividend yet. So, cum div price, everybody knows what is cum div ex div, right? Cum dividend ex dividend. So, cum div price must be this price plus the dividend, right? Okay? Now it's important to remember this because when do you exercise your call if it pays a dividend? Before or after? Before, right? So therefore you need to know the cum div price, right? You need to know the price before it pays a dividend because that's the price you're going to get. Yeah? So that's important to remember. Okay, so remember the numbers. Okay? So the value of your call at this point, end of the second period, strike price of 100, this is in the money, out of the money, out of the money, right? So therefore you have 38 and 0 and 0, okay? Discount that to one period, okay, PCU plus 1 minus PCD divide, discount by one period gives you 2172. Okay. Now, so what we're saying here, 2172 plus 0 is 2172, right? So what we're saying at time T1 is that if you were to exercise your American call, you actually would receive 22.99, right? Because cum div price of the stock is 122.99, strike price is 100, so your intrinsic value is 22.99, so you actually receive 22.99. However, if you don't exercise, the value attached to your American call is only 2172, right? So you would want to exercise, okay? Now, in the event that you still don't want to exercise, in order to calculate the value of your American call in T0, you will then have to use 22.99 and not 21.72 because this is the value that you're going to realize if you were to exercise. Okay, a significant distinction between American and European. If this were an European call, you would continue to use 21.72 because you cannot exercise, right? So you cannot. So you have no chance of getting that 22.99 anyway, right? So you have to use 21.72. However, if this is an American call and you exercise, you get 22.99. So in order to value to time 0, you use 22.99 in your formula instead of 21.72. Okay? So you can see from this slide that that an American call would be worth more than a European call if the stock pays a significant dividend. Okay? Any question? So you can also see, therefore, that there is value in the ability to exercise early. Okay? Now, if you were to try out this calculation again, but you use a different dividend number, a smaller number, you may find that it's not significant. Okay? So it's not just that a stock has to pay a dividend, it has to pay a sufficiently large dividend. Okay? So the larger the n is, or the larger the number of iteration is in your binomial, the closer the value approaches Black-Scholes. Okay, this is a slide that I'm using last week's example. Okay, so the same parameters from last week. I just want to show you how you can calculate your risk-free rate and how to calculate your U and D. Okay, and then with that, we will attempt to calculate the value of that option and see whether it is within the bid-ask range of what we saw in last week's slide. So taking last week's slide of ANZ example, June 16 call, and using these three formulas here, you can calculate. So 1.05, because in last week's example, we said interest rate is 5%, right? And we also say that the stock price is 1574 and the number of days to expiration was 86, if you still recall last week's lecture. No? Okay, you can always refer back to last week's slide, okay? So using those numbers, you find that 1 plus R, 1 plus 5%, 86 days to expiration gives you 1.1% interest rate. 1778 here is the middle ground of your implied volatility. If you look at the slide of last week, we have buyers implied volatility, we have sellers implied volatility, right? Do you remember? So we have two volatility numbers. However, you may not see two volatility numbers depending on where you look at. Okay, FR may give you something else, Australian may give you something else, Adelaide, what is the period? Adelaide now, is it? Adelaide. Okay, if you look at different publications, they may give you different numbers. Some will give you implied buyer plus implied seller, some gives you only one number. So 1778 here, we are taking the middle ground between implied buyer and seller volatility. Okay, so stick in all the numbers, you have all these values here. So what's the value of a call? The greater of 0 or intrinsic value, right, at expiration. So we've calculated SU to be 17 and SD to be 14. Strike price is 16, right? Okay. Does everyone know how to read this? You do, right? You must by now, right? Okay. So stick in the numbers, you find that the value of a call if the stock price goes up is $1.15 because it's 0 if it's out of the money. You can calculate P since you've calculated your R and D, R, U and D, and stick in the formula. Okay, again P, CU plus 1 minus P, CD gives you 62 cents. Okay. Now in last week's slide, we saw that the bid-ask spread was 47 and 57. So if you take the middle ground, it's 52 cents. So we're actually 10 cents out of the bid-ask spread, right? So that's not very good, because if you're out of the bid-ask spread, you can't trade, right? Nobody's willing to buy from you or sell to you. So the reason for that is because we consider 86 days, right? Was it 86? 86 days as one period. So the stock price doesn't jump from one number to another number in all of a sudden, right? When you have 86 days. It will go up, down, whatever, you know. So many moves before it reaches the price at the end of 86 days, right? But because in our example here, we consider 86 days as one period, so therefore the value that we calculated cannot be so accurate. Now if we were to consider this in real time, such as using the Black-Scholes, or even with the binomial, if we were to slice the 86 days into 86 periods, or maybe even 300 periods or 500 periods, then you find that the value of 62 cents is going to get closer to 52 cents. Right? Does everyone follow? Okay? So as n approaches infinity, that gives you the same figure, and you won't approach the Black-Scholes figure. Now, what I would like to do is to show you this one. This is a backup for you in case you can't use the app for whatever reason. Okay, so you're not lost. You still have something to fall back on. Okay, but however, if you can, update your software, use the app, because we spend a lot of time developing the app, so and it's for students' use. So I hope you use it, and you can tell me whether you like it or not, whether it's good or not, or whatever, right? So I can hopefully improve on that. So try and use the app. Everybody knows where to get, right? UOA option pricer at App Store. Okay, so if you don't have that, at least for now, this is what you can do. Okay, I have a spreadsheet here. This is available on my uni. It calculates using both Black-Scholes and Binomial. You can account for individual dividend payment, or if you have a dividend yield, you can use a dividend yield. So let's see what happens. So the stock price was, in the example, was 1574. Strike price. Now you can see that as I key in the numbers, the Black-Scholes value changes immediately because that's on that's continuous time, right? However, with the binomial model, I have to specify the number of steps, and then I have to hit run. Okay. So strike price was 16. Time to expiration was 86 divided by 365. Volatility was 17.78, and interest rate was 5%, right? So there was no dividend. So if you look at one period, which we assume in the slide just now, and you hit run, you find that it's 62 cents. Okay? Now, if I were to change this to 86 days, because it's 86 days, right? So I assume now instead of one period, it's 86 periods. Let's see what happens. It becomes 50 cents. Okay? So the message here is that as you account for time more accurately towards reality, such as continuous time, then the accuracy of your calculation gets closer and closer to Black-Scholes, or closer and closer to what is valued in the market. Okay? Any question? No questions? Today's lecture is clear to all? So make sure when you revise, you are very certain which number to use, okay, and how to interpret the numbers. Okay, thank you.